It's that time already. We're moving from SP to SQ, from GF6 to GF7. And of course, that means changes all across the engine oil world. Now, it seems like not that long ago, we were moving from SN plus to SP, or at least it feels like that anyway. It feels like things are accelerating a little bit. But SQ and GF7 are now upon us, or at least they will be in March. So what exactly are the changes and how are they different from GF6? What does that mean for you? Let's take a look. Now, if you remember, these are the people that set the rules, the American Petroleum Institute. And then there's ILSAC, which is really an organization that is made up of the automotive manufacturers. Now, this makes it a little bit different from what we see in Europe. It's a petroleum institute. So they deal with things like drilling, completions, refining, as well as fuels and lubricants. That obviously intersects with the motor vehicle manufacturers when it comes to both fuels and lubricants. Now, across the ditch in Europe, right, the ASEA engine oil sequences are effectively dictated by the car manufacturers. So here we have the involvement of the actual petroleum industry. Now let's remind ourselves a little bit of the history, right? So going back to, say, the early 2000s, right, we've had developments which have gone from GF4, GF5 to GF6, right? Similarly, there's some stuff that's been going on in Japan as well as Europe, and these have often mapped onto different emission regulations. And if you remember in our video when we talked about SP changes, really we're going from a paradigm of emissions control, so that is what's coming out the tailpipe, more to something about fuel efficiency. So we kind of talked about the fact that the amount of NOx and particulate matter was coming down so dramatically, we were kind of in that area of diminishing returns. And so now what we're controlling is effectively CO2 emissions, but the only way that you can really do that is by increasing fuel efficiency. For some historical context on what US real MPG looks like per year, right, here is the average, and it has been trending up. And that's a good sign that all our vehicles are becoming more and more efficient. Now, the ways that we're doing this are varied, right? We tend to have much more smaller displacement engines. We do turbocharging. There's a lot of, obviously, direct injection. That has caused issues with LSPI, which we're having to deal with in the oil formulations. And we're also seeing the advent of a lot of stop-start. There's a lot of hybrids, and that's all driving this increase in MPG. Now, if we were to look at a spider chart of performance, right? So here, as you go from the middle to the outside, that is a level of increasing performance. And GF5 looked something like this. Now, GF5 was effectively SN, right? So the API SN series had this kind of performance profile. If we were to talk about SN Plus, if you remember, SN Plus was actually an intermediary between GF5 and GF6 because we encountered all these issues with LSPI. And so the performance profile was very similar to GF5, except that we added on top some tests around LSPI, and that's the sequence 9, right? So that's why you see that deviation in the performance profile. When we went to GF6, that was a pretty decent change, right? Because we added the timing chain wear, but there was also some additional kind of performance criteria around most of the other performance metrics, and we changed a lot of the sequence testing as well. And now what we're doing with GF7 is we're increasing the performance envelope across a range of different dimensions, but the additional test that we are running here is what we call aged LSPI. So originally, what we were only testing was its propensity for low speed pre-ignition for new oils. Now what we're saying is, well, LSPI can happen at any point in the age of the oil. So let's test what its propensity is like if we have an older oil, and that's the modified sequence 9. So again, in terms of actual tests, so as we evolved from SN to SN+, we added the test for LSPI, then we changed a lot of the tests when it came to SP, and now as we're going to what we would call SQ, there's not a whole lot of changes on the actual tests themselves, although we are kind of making the performance criteria higher, and we're adding that aged LSPI test. Now, GF7 is actually going to be split just like its GF6 counterpart. So in GF7, we're going to have a GF7a as well as a GF7b. Now, GF7a is going to be related to anything which is a -20 or a -30 viscosity grade. So 0W20, 5W20, etc. GF7b is going to be a little bit like GF6b was, in that it deals with the 0W16 category. Now, if you've been following along with this channel, you'll know that the SAE, which is the Society of Automotive Engineers, actually has two other viscosity classifications which are lower than a 0W16. So we've got a 0W12 as well as a 0W8. And it looks like those viscosity grades are not going to make it into this specific version of GF7. Now, I find that quite interesting because a lot of the Japanese manufacturers are starting to demand 0W12s and 0W8s, which means that those oils that are required for Japanese vehicles won't actually get an API or an ILSAC rating. Now, what are the kind of performance dimensions that you could see across these? Well, we've got a whole bunch of tests which are dealing with things like deposit control, wear protection, LSPI, GPFs, protection from gels. They're doing a whole bunch more testing around seal material compatibilities and seal life, so that's good. One thing that is different is the fuel economy tests. So GF7b has a slightly altered fuel economy test, and that's because GF7b, being a lower viscosity grade, is really targeting that sort of fuel economy spec. Now, one of the ways that we're achieving that slightly higher fuel economy is because we're altering the HTHS. So remember, HTHS is high temperature, high shear viscosity. This is the kind of viscosity where we are simulating conditions that you might see, for example, in the cams and lifters, right? And what we are trying to show is that we have adequate wear protection even at lower HTHS viscosities between 2.3 and 2.6 millipascal seconds. So that's a really, really quick overview of the new changes for SQ as well as GF7. Now, formulation-wise, what kind of changes are we going to see? Well, from my understanding, there were a number of oils that were already on the market which did not need to be adapted in any way to meet the GF7 criteria. So say, for example, the hurdle rate was here for SP, and you were able to significantly beat it on most of the performance dimensions. In some cases, the formulations had enough headroom that they are actually able to be approved for GF7 already. So in some respects, maybe we won't see a lot of changes. Remember, when we needed to protect against LSPI, the major change that we made in the formulations was cutting down on the calcium detergents and probably increasing the amount of magnesium detergents. We've already made that change, so we still have that LSPI protection that carries over. It was merely an extension of that test to ensure that the LSPI protection carried over for aged oils.